The question will be to prove that this statement is correct. On the left hand side you have the sigma notation. You have k is equal to 1 and it's k squared up until n. Now we need to write out this just to make more sense of what it's saying. So you'll start with k is equal to 1, so it's 1 squared plus, and the next term will be 2 because k is 1 and then it becomes 2 and you replace it each time into the k. So it's 1 squared, 2 squared plus 3 squared, and it continues up until the n there shows you it continues up until n squared, and it's equal to n over 6, n plus 1, 2n plus 1. So we can work with this statement. Now we need to prove that this statement is correct, and we do this by using steps. Step 1, and this is always the steps we take, we look at n is equal to 1. Now if n is equal to 1, we know the left hand side, the first term will be 1 squared, and that's just 1 squared, and that's just 1. On the right hand side you replace the n with 1, okay, because the n is 1. Yes, you replace 1 into the n there, into the n there, and into the n there, so it's 1 over 6. You place 1 in there, so it's 1 plus 1, and 2 times 1 plus 1. Okay, so the 1 is replaced. Okay, or the 1 is replaced into the n. Then if you just simplify this, it's 2, and 2 times 1 plus 1 is just 3, so it's 1 over 6 times 6. Okay, and remember when you write it like this, it actually means 1 over 6 times 6 over 1, because this is actually on 1. And when you do multiply fractions, you multiply top, multiply bottom, so it's 6 over 6, and that's just equal to 1. That was now step 1. So let's look at step 2 we need to do to prove that this statement is correct. Step 2 is actually an easy step, because you just say accept that the statement is true. Accept that the statement is true for a natural number n is equal to k. Accept that the statement is true for a natural number n equal to k, and all you do is you just replace k into the original statement. So you just replace k into the n here, the n there, the n there, and the n there. That's all you do in this step. So you have 1 squared plus 2 squared plus 3 squared, and it continues up until k squared, because you replace the n with k. Then you have k over 6, so you replace the n with k. Then you have k plus 1, and you have 2k plus 2. Okay, that's step 2. Now step 3. This is the more difficult step, but if you just work systematically, it should work out fine and you won't have any troubles. When you do step 3, start with the right hand side, and then you know what you want to work towards with the left hand side. So let's start with the right hand side. Remember again, we replace into the n, we put k plus 1. So if we go back to the original statement, so into the n we put k plus 1. We put k plus 1 in there, put k plus 1 in there. Okay, so let's go back. So you say on the right hand side, it's just k plus 1 over 6, because I replaced into the n k plus 1. Then it was n plus 1, so now it's k plus 1 into the n's place plus 1. And then, oops, there's too many brackets, just keep one bracket there. The original bracket is that. Then you have 2, and you into the n's place you put k plus 1. Okay, and that's plus 1. Then let's simplify this. This is k plus 1 over 6. Then you have k plus 1 plus 1. This brackets can fall, these two brackets can fall away. So it's k plus 1 plus 1, so it's just k plus 2. And then it's 2k plus 2. If I multiply the 2 in there, 2k plus 2 plus, then that one goes there. then you have as a solution k plus 1 over 6, and then you have k plus 2, 2k plus 3. But let's write this a bit neater so that we know where to work towards. Now, don't multiply out the brackets and so on. Just write it a bit neater. So, because you know this is going to be actually on 1, so we can write it as you multiply the top ones with each other, and at the bottom you multiply the 6 with the 1. That's your right hand side. Now we know what to work towards on the left hand side. Now we know that the left hand side was 1 squared plus 2 squared, and it continues up until k squared. Remember that, and then we need to add the k plus 1 because the n becomes k squared, but the k plus 1 squared, because in the n's place we put k plus 1. But remember, the term just before k plus 1 must be k squared, and we use this method because we know 1 squared up until k squared is equal to, and that's why we did step 2. We know that 1 squared up until k squared is the same as k over 6, k plus 1, 2k plus 2. So we just replace that part. We just replace with step 2's statement. So that's just going to be k over 6, k plus 1, 2k plus 1, and then you have plus k plus 1 squared, this one there. Okay, so now we just need to simplify this. And how will we do that? Well, let's look at let's get a LCD here, the lowest common denominator. And what will that be? Well, we know for this one, the 6 will be the denominator, and here it will be 1. So if we look at 6 as our denominator, we know it's going to be k plus 1, 2k plus 1 for this side, and for that side, well, we need to multiply 6. And you probably use different methods to make sense of this, but what you do is you ask yourself, what did I multiply with the 1 there to get to the 6? Well, I multiplied 6, didn't I? And what you do at the bottom, you must also do at the top, and that's where 6 times k plus 1 squared is just 6k plus 1 squared. Now we can simplify the top one, and here you must be careful now not to create too much work for yourself. You can take a k plus 1 out there and there. So let's factorize that, and I don't have much space left, so let's look at this. So it's k plus 1 I'm going to take out, and I end with k 2k plus 1 plus 6k plus 1, and you close the brackets. See, I took out the k plus 1, so what am I left with? K and 2k plus 1. If I take out k plus 1 once, I'm only left with 1 there. Okay, now we need to simplify. Oh, and it's over 6, don't forget that. Okay, so then you have k plus 1. Let's simplify that bracket. Now what will that be? You have 2k squared plus 2 plus k, sorry. So it's k times the 2k is 2k squared, and the 1 times the k is just k. Then plus 6k plus 6 over 6 there. Just remember your brackets here, otherwise it looks as if the 1 is multiplied with the bracket and not the k. Then you have k plus 1, and then you have 2k squared plus k plus 6k, so that's 2k squared plus 7k plus 6. Then, well, then you can factorize this, can't you? You can say that is 2k in the one bracket and the k in the other bracket. So you need to revise your factorization to get this one. What do we multiply with 6? But be careful, because this 2 will also influence your your factors. So what we'll see is we'll put the 3 here, because 3 times 2 is 6, and the 2 times the 3 there is 6, and the 2 times the k is 2k, so we won't use that one. What we'll do is we'll use the 2 there, and the 3 here. Okay, and obviously the when you look at the right hand side from the previous, or the right hand side just on top here, you will this will actually give you the indication of how it will look like anyway. So you have 2k plus 3 and k plus 2, so the 3k is 3k, 2k times 2 is 4k, so it's 4k plus 3k is 7k over 6. Then you can see your left hand side is equal to your right hand side. So we've proven that. And then step 4 is just a normal usual conclusion, and it says the statement is true for for n is equal to 1 if it is true. I'm not going to write out everything, but please do, when they ask you the question, if it is true, if true for n is equal to k, then also true for n is equal to k plus 1, and then I'll just move a bit down. Oh, I can't, sorry. Then true for all n natural numbers n. And that's your proof. That's just 4 steps you take.